Have scientists found our first exomoon? Looks like they still need more observations to be 100% sure. The moons in our solar system are very diverse, some with liquid water, some that are potentially habitable, so being able to observe moons in different solar systems would give us a whole new treasure trove of interesting worlds to study. The team of astronomers from Columbia University sifted through data from 284 Kepler measurements of transiting exoplanets. A transit happens when a planet passes directly between us and its star and blocks out a small portion of the star's light, which produces a dip in the amount of light coming from that star over time, called a light curve. If there's a moon on either side of the planet, we might be able to see a second, smaller dip in the light curve. Making transit measurements and processing the data into a light curve can be very tricky though, so scientists need to observe multiple transits in order to get convincing evidence of an exoplanet or an exomoon. Out of the 284 planets the team looked at, they found one planet with an extra wobble in its light curve that might be a moon. This planet, Kepler 1625b, orbits its star once every 9.5 months, so it takes years to observe multiple transits. The team only had Kepler data from 3 transits of this exoplanet, so they sent a proposal to the Hubble Space Telescope to capture more data of this possible exomoon. Hubble can measure light curves much more precisely than Kepler, so Hubble can more definitively confirm or disprove the existence of this exomoon once it gets multiple transits. So far, the team of astronomers has collected Hubble observations of one transit of exoplanet Kepler 1625b. Hubble measured the light coming from the star over a period of 40 hours. About 7 hours into the observation, the planet started its transit, which was about an hour earlier than predicted. A tantalizing piece of evidence that the planet has a large moon, because a moon would cause the planet to wobble in its orbit. The planet transited across the face of its star for 19 hours, as expected. Then, about 3.5 hours later, a second, smaller dip in the light curve started. That right there is intriguing evidence of an exomoon. The Hubble observation unfortunately concluded before the possible moon finished its transit, so Hubble hasn't yet observed a full transit. This light curve appears like it shows an exomoon, but we can't say it's a definitive detection until Hubble observes at least one more transit. If this is actually a moon, what do we know about it? The planet Kepler 1625b is likely several times the mass of Jupiter. Its possible moon appears to be about the mass and radius of Neptune. The ratio between the mass of this planet and its moon is about the same as between the Earth and our moon, but scaled way up. Neptune-sized moons are obviously not something that exists in our own solar system, and we're not sure exactly how such a moon would form. When scientists first started discovering exoplanets, a lot of them were several times the mass of Jupiter because big planets are easier to detect. So a similar thing may happen when discovering the first exomoons. Finding planets and moons so different from the ones in our own solar system gives us a lot more knowledge of the many diverse ways planetary systems can exist. In the near future, scientists hope to use the Hubble Space Telescope to try to confirm the discovery of this exomoon, and then they'll use Hubble for follow-up observations of other planetary systems discovered by observatories like Kepler and the recently launched Transiting Exoplanet Survey Satellite, TESS. And then the upcoming James Webb Space Telescope will be able to take high-precision measurements in infrared wavelengths, which combined with Hubble will allow for detailed characterizations of a whole bunch of really interesting exoplanets and likely exomoons. So, if you like planets, and honestly, who doesn't? Stay tuned to learn about all sorts of fascinating new worlds.
The Hubble telescope is composed of several different instruments, and outside of those is something called the primary mirror, where all the light bounces off of and goes into the instruments. That's where the flaw was. So the problem was something called a spherical aberration. What exactly does that mean?
It means the primary mirror had the wrong shape. That is, it's a shallow bowl, effectively, that brings light to a focus. It's a little too shallow. It rendered the telescope fundamentally unfocusable.
So it was a little bit out of tolerance on that primary mirror, and it was affecting all the instruments in the Hubble?
All 5 scientific instruments on the Hubble depend on a sharp image. That's the whole point.
So So Hubble's sitting in the doctor's chair and it has the eye chart in front of it, and instead of seeing the letter E, it sees the letter F.
Worse, what it sees looks like a squashed spider.
But it's way up in space and you can't get it back here, so how do you fix it?
Well, if you're born with eyeballs that don't quite work, you don't go and buy new eyeballs, you buy a pair of glasses, and that's the approach that we took.
The wide field and planetary camera known as WIFPIC relied on light from the primary mirror.
The light from that primary mirror all comes down to a focus inside our camera on a mirror that looks just like this. And this is now an opportunity for us to correct the curvature, the shape of the primary mirror right here. We simply put the same error in, reversed, and corrected. The Hubble telescope was designed from the outset to be serviced every 3 years by astronauts.
Andrew, you can take it away.
The camera is designed to be replaced in space. That's the one thing that was really just waiting for us to take advantage of.
Looks like it's in there. Yeah, mine's beautiful. Okay.
So what was the outcome?
At the Space Telescope Science Institute, way down in the basement, there were a bunch of us watching. And the first image, which was of a star, looked good. So we knew right away that we had a fix. And everything that Hubble was supposed to do was now going to happen.
So I think I speak for everyone when I just say thanks to you and your team for all the hard work you put in fixing Hubble, because now we have these images really forever that we can appreciate. WIFPIC 2 went on to become the workhorse for the Hubble telescope, and it lasted for more than 15 years. Well, now you guys can check it out at the National Air and Space Museum in Washington, D.C., and we'll see all of you on another episode of Crazy Engineering.
Our understanding of our universe
is just the breadth of the scientific discoveries it's been able to make. Everything from the age of the universe, proving the existence of black holes, to discovering brand new things, like the universe is accelerating due to mysterious dark energy.
Hubble has consistently taken us to places we've never been, visually, of course, and empowered us to answer questions that in a previous generation of telescopes we couldn't even pose.
So I think what excites me is that it shows us the wonder of the universe, places we can't get to right now.
From comets and asteroids to some of the most distant galaxies yet discovered, Hubble continues to revolutionize astronomy in our solar system and beyond. Hubble has changed the way we view our universe and ourselves. We're on a never-ending journey, and the Hubble Space Telescope celebrates its quarter century of exploration as part of that journey.
"20 years after launching on a space shuttle and opening its instruments to the farthest reaches of space, NASA's Hubble Space Telescope has become synonymous with exploration, discovery, and even a bit of luck.
One of the things that Hubble has done is it really taught us something about our place in the universe and our role within it. We want to know, how did the universe start? How did our galaxy start? How did the Earth start? How did life on Earth start? And we also want to know, how will all of these things end?
When the telescope arrived, there was a lot of anticipation because there was so much extraordinary effort required at KSC in order to assure that the telescope was going to be able to maintain in the kind of environment that it had to be, and that meant a cleanliness standard that was extremely pristine, far beyond anything that we had ever launched before.
With years of design and construction behind it, the Hubble was sealed inside Discovery for liftoff. The Hubble Space Telescope flew into the national consciousness on April 24, 1990, inside the payload bay of Space Shuttle Discovery.
The launching of the telescope itself was a huge deal because the Hubble Space Telescope was long awaited, and it was supposed to be launched in the year that the Challenger accident happened.
Hubble was different from land-based observatories because it would operate from a point hundreds of miles above the distorting effects of Earth's atmosphere. Though its 94.5-inch mirror is small compared to those built on the ground, the telescope is huge by spacecraft standards. At more than 43 feet long, the telescope took up most of the shuttle's payload bay. But as large as Hubble was, it was sent up with a tiny flaw in its main mirror. It was an imperfection less than the width of a human hair, but it was enough to blur Hubble's images and leave the observatory's potential in doubt.
To find out 2 months after launch that it was launched with a misshapen mirror was crushing to NASA.
When the telescope had its spherical aberration and needed glasses, we had already built expectations to the point that they were expecting to see these kind of things right away, when in fact, even if the telescope had worked, where it's going to take astronomers a considerable amount of time to get some of that data and then to see what else Hubble was going to find that we didn't know about.
The telescope was quite powerful even with the flaw, but NASA knew it would have to fix it. So engineers set out to build Hubble a set of contact lenses.
So I think that was probably our biggest challenge, was to try to make people realize that these things were still going to happen. We just needed a little time to fix this problem.
Being able to restore the Hubble Space Telescope's observational capabilities was incredibly important to the agency, and they put together a great plan to do it.
Astronauts made 5 back-to-back spacewalks during the repair mission, a first. They spent more than 35 hours working on the telescope in the payload bay. The Hubble repair had effects reaching beyond the telescope's health as well.
This mission wasn't just about restoring the Hubble Space Telescope, it was about whether NASA had the capability to go off and build the International Space Station.
The problem was fixed to the extent that it never occurs to anybody to even think about it anymore, because the results are just so dramatic from the Hubble.
The first images from the telescope proved the servicing achieved its goal. The Space Telescope was free to look into the farthest distances ever seen, nearly as far back as the beginning of the universe. Astronauts made 4 more servicing flights to the Hubble Space Telescope to upgrade its instruments and replace critical components.
We did it in a way that we knew it was the last time we were ever going to visit the telescope, and we had to do everything to it that we wanted to do if we wanted it to last a lot longer. So that made it more complex. And when the mission was over, the feeling was we'd done it.
They had seen different worlds for the very first time through the eyes of the Hubble Space Telescope, and it's really expanded the general public's view of the universe, how the universe began, what the ultimate fate of the universe is going to be. It has ignited, it just has ignited the imagination of the collective American public.
The Space Telescope repaid each mission with more incredible views of space that all could see and appreciate. Hubble observations astounded researchers by showing the universe was not only expanding, it was speeding up.
Imagine your amazement if, when I throw these keys up, you would suddenly see these keys accelerating towards the ceiling. This is what we discovered. This was extraordinarily surprising, and it led to this notion of dark energy that is pushing on the universe to accelerate.
Once we began to get things back from Hubble, the scientists were beginning to see physical processes going on that they didn't really understand and hadn't been able to see before.
20 years after opening a new eye on the universe, Hubble continues to dazzle by reaching farther back in time and space.
The light that we're just now receiving from some of these galaxies and different objects show younger and younger galaxies and stars, the light for which, when they left that galaxy, the Earth hadn't even been formed yet. That's how far back in time Hubble is seeing.
We're talking about questions that a few tens of years ago we didn't even know to ask.
The whole thing is a very storied program from the very first launch until the last servicing mission.
There are more questions for astronomers to answer, and Hubble will remain in orbit to answer them for years to come.